Good day everyone, we are Group 1 and today we will present and discuss all the results that we obtained from the experiment that we conducted, which is the minus 1 element technique or the Moet. The remove nutrient elements that were assigned to us are nitrogen, phosphorus, and potassium. Our group was also tasked to handle and observe the plant that contains all the essential nutrient elements plus the fertilizer urea. So before we proceed with the discussion and presentation part, allow me to give you a brief background about this experiment. So we started this experiment with the preparation of pots. After a week, the soil inside those pots were treated. So treated in a sense na we added all the nutrient elements except for one. To give you an example, in our group, our first pot, we add or we mixed into the soil a certain sachet from the Moet kit. So it is labeled minus N, meaning all the essential nutrients are there except for nitrogen. So ang mangyayari, yung natural presence or amount lang ng nitrogen na meron yung lupa na yun lang yung pagkukuhanan ng palay all throughout nung life cycle niya. So hindi naman totally na-eliminate yung nitrogen. Um, Hindi lang siya dinagdagan or inimprove. So this will allow us to see if yung soil ba na yun is sufficient or not with the nutrient of nitrogen. So same with the other nutrients in this experiment. So yung plant or yung palay, to be specific, will manifest or show symptoms if it needs more or less of those nutrients. So this experiment lasted for 59 days, but the data that we will be showing to you later on will just be until day 35. So let's move forward with the discussion part, and let's start with the complete path.
Good afternoon, sir. I'm Hannah Ignacio, and I will present to you the data we collected from Complete Plus Urea. So, we started collecting data in the second week. So, for the second week, plant 1, which is in the left side tiller of the plant, is taller than plant 2. So, in leaf length, of oldest leaves of plant 1 is smaller than plant 2, while youngest of plant 1 is taller than plant 2. In leaf width, plant 1 and plant 2 is similar except that the center leaf width. So in tiller, they have both one tiller, and for LCC, the oldest leaf of plant 1 got 3, while plant 2 get 2, and for the youngest, plant 1 got 5 and plant 2 got 3, which means plant 1 is darker than plant 2. For the third week, plant 1 is taller than plant 2. In leaf length, we use another part of the plant because the previous plant we used to collect data is died. So the leaf length oldest leaf of plant 1 is taller than plant 2, while youngest of plant 1 is smaller than plant 2. In leaf width, plant 1 and plant 2 is similar except to the bottom leaf width. So for the tiller, plant 1 have 1 tiller, while plant 2 have 6 tillers. So this is because the tiller of plant 1 is much better than plant 2 when we plant it to the plant. And for LCC, the oldest leaf of plant 1 got 2, while plant 2 got 5. And for the youngest, plant 1 and plant 2 are both 4, which means plant 2 is more darker than plant 1. For the fourth week, which is day 28, plant 2 is taller than plant 1, and in leaf length, same with the last week, oldest leaf of plant is taller than oldest leaf of plant 1 is taller than plant 2, while youngest of plant 1 is smaller than plant 2. Uh, in leaf width, plant 2 is more wider than plant 1, and plant 2 still have more tiller than plant 1. And for the LCC, the oldest leaf of plant 1 got 5, while plant 2 got 4, and for the youngest, plant 1 got 3 and plant 2 got 5. Meaning, the oldest leaf of plant 1 is more darker than plant 2 and the youngest of plant 2 is more darker than plant 1. So, for the last week, which is day 35, plant 2 is taller than plant 1. In leaf length, we use again another part of the plant because the previous plant we used to collect the data died. So the oldest of plant 2 is more taller than plant 1 and their youngest is the same. So in leaf length, plant 2 is more wider than plant 1 and plant 2 still have more tiller than plant 1. And for LCC, oldest and youngest of plant 1 and 2 is both 4 and 3 respectively, meaning they have the same color. And that's all the data we collected from Complete Plus Urea. Thank you po.
Good day everyone, I am Travis Shabsamis and I will be presenting the documentation part of the Complete Pasuria. So this is what the Complete Pasuria looks like in 14, 21, 28, and 35 days after transplanting. So something that we have observed during those days is that during the early stages, like around 14 days after transplanting, the rice seemed like it was drooping, but after a week has passed, it began to grow normally as it should be. So this is basically what a rice given with all the nutrients it needs should look like now.
My name is Juan Cedric Sigiano from BSA 2-1 from Lab B. So let's just guys discuss the nitrogen. Or what are the importance of nitrogens here in our plants? So nitrogen helps rice, especially my own rice. So nitrogen helps rice plants grow bigger, greener, and produce more grains. And it makes the plants strong and healthy, but too much can cause problems like falling over and more pests, and can affect the photosynthesis of our plants, especially the rice.
As for the given set of data on the table of the minus nitrogen, we can see the following data gathered on the left, which is the height, length, diameter, number of tillers, and the LCC chart gathered, and a P1 and P2, where P1 as plant 1 and P2 as plant 2. And the two data on length and diameter were the youngest and the oldest. We have collected data gathering from 14 days after transplant to 35 days after transplant, varying from 14, 21, 28, and 35 days. As we can see in the 35 days after transplanting, there are significant difference between the P1 and P2, and in the height have almost 14 centimeters, and in the LCC is almost the same, but the youngest in P1 is more darker, having a number 4 in the chart, while the P2 have 3, which in terms of the LCC in the 35 days of the gathered data, and a difference between the complete plus urea treatment on the other hand, and previously said by my group mate. So there are a significant difference between the complete plus urea treatment in the -1 element technique and in this minus nitrogen technique.
So we come up with minus nitrogen here in our Moet or -1 element technique. So first we must say that the gathered data we have like plant height, leaf length, leaf diameter, and number of tillers. So what are the importance of those data here in our presentation? First, the plant height, where the nutrients deficiency often stunt the plant's growth. If the height is much lower in a certain treatment, it hits the missing nutrients nutrient is important for stem and overall growth of the plant. So that's why we collect the plant height of the plant in often days 14, 21, 28, and 35. And the importance in leaf length and leaf diameter kung bakit natin siya kinukuha is to know because healthy leaves are usually bigger and thicker, and smaller and narrow or fine leaves can can signal specific deficiency, for example nitrogen and other essential elements. And when we get numbers of tillers, because a good number of tillers is a sign of healthy rice, fewer tillers could means that plant is stressed from lacking nutrients like nitrogen or phosphorus. So that's why we gather all those data from our plant in our -1 nutrient technique.
Good day, sir. I'm Hannah, and I will be discussing the deficiency symptoms of minus N or minus nitrogen in rice based on our observation and our experiment in Moet. During the experiment po, we observed that the leaves of rice in the nitrogen or minus nitrogen treatment is more yellowish than the other treatment. And from that yellowish stage po, the leaves of the rice will eventually die. And the cause of the yellowing color of the leaves is because of the lack of nitrogen in the soil. Since nitrogen is the key component of chlorophyll, which is responsible of the green pigment of leaves, the lack of nitrogen may affect the color of the leaves. We also observe that compared to other treatment, specifically with the complete plus urea, the minus nitrogen have lesser tillers and shorter than the other treatment. It is because of the nitrogen is the building block of amino acid and protein, which is necessary for cell growth and division in the axillary buds, where the tillers originate. Due to lack of nitrogen, the development of axillary buds is reduced, which may result to less development of the panicles where the grain develop that may potentially affect the yield of the rice.
In the conducted Moet or -1 element technique experiment on rice growth in buckets, clear difference were observed as our group observed. The subjected to -N nutrients treatment and those given a complete nutrient solution supplement with urea, the rice plants lacking nitrogen display classic deficiency symptoms such as chlorosis and the start of yellowing of older leaves throughout the span of its vegetative state, and stand plant height, thin and spindly stem, and a marked reduction in tillers capacity, which is more on lack of tillers producing of those rice plant. These symptoms indicates nitrogen's central role in chlorophyll synthesis in protein formation, which are vital for photosynthesis and vegetative growth. Because of what my partners have said earlier, the nitrogen is one so essential for chlorophyll formation of the plant. And conversely, plants treated with the complete nutrients solution shows vigorous growth, dark foliage, and greater tillage production, which is we can see that almost 29 tillers are producing a complete plus urea treatment, while in our minus nitrogen is almost 23 tillers are the highest. And in overall healthier appearance, the start of the treatments clearly emphasize the significance of nitrogen in achieving optimal rice growth and productivity. The data gathered compare that nitrogen deficiency is rice leads to poor development stage and likely to reverse reduction in final yields if not corrected. Moreover, the experiment illustrate the effectiveness of the Moet method as a practical, visual, and field-based diagnostic tool for identifying specific nutrients limitation aiming farmers and researchers in designing precise fertilizer management strategies, such as the LCC chart, where you almost can see the leaf color chart. If the plant is lacking of nitrogen, especially you can see its symptoms because of the yellowing of the leaves of the rice. Overall, maintaining the nitrogen supplement is critical for maximizing rice yield potential, and early detection of nitrogen deficiency can prevent severe crop losses. The comparison almost underscored the importance of integrated soils and plant tissue analysis with fields observation for efficient treatment of nutrients management in rice farming. And that's how it is. But and one thing is for sure, that napansin namin is our plant almost 6 weeks na gathering of data have produced panicles. So how it produce panicles while it lacks of one essential nutrients, which is nitrogen, which is kailangan mo kasi it is a part of a macronutrient. So here's the answer. As we go back to the law of the minimum of law of Liebig, na all 16 essential nutrients are needed by plant, but if one lacks, it means it can affected the yield of the plants. So here it is, the plant that has enough nitrogen, which is complete treatment, which is rice, will produce more or bigger panicles each, which plenty of rice grain inside. Na meron siyang rice grain inside, but the plant with lack of nitrogen or have the minus nitrogen will produce also a panicles, but it will have a fewer or even emptier grains inside because the plant was too weak to supply enough energy for proper grading. So applying the law of minimum is essential for planting rice or any other crops. So in short, with enough nitrogen, the rice plant might still flower, but it will make less rice, and some grains may be small and shrivelled or missing inside the panicle. So nitrogen is very essential, mostly on or most important in rice production, and so on.
So, this table represent po yung growth ng plants po natin from day 14 to 35 ng phosphorus treatment po. So, ayun, nakita naman po natin sa day 14 na mas malaki yung plant 1 natin by 4 centimeters. And sa 21 day after the transplant po is pareha silang nag-increase ng height, reaching 44.5 cm, and yung plant 1 po yung kanina, and yung plant 2 reaching the 43.5 cm po natin. So sa leaf length naman po ng ating day 14 is yung oldest leaf po natin is 8.9 cm, while the youngest leaf is 9.2 cm, na parang walang pinagkaiba sa oldest and youngest leaf ng plant 2 natin. Kasi 8.4 yung plant 2 oldest leaf, and the youngest is 9.6. Unti lang po yung pinagkaiba, point lang. And sa nung day 21 naman na po, day 21 after transplant, yung oldest leaf po ng plant 1 is umabot na ng 13.4 cm, while the youngest leaf is umabot ng 14.4 cm. Na ganun din po, parang unti lang po yung in-increase or pinagbago sa plant 2. Yung oldest po ng plant 2 is 14 cm na sakto, while yung youngest po ng plant 2 natin is 12. So, sa week naman ng ating day 14 is yung oldest natin nag-start sa 2 millimeter to 5 millimeter to 1 millimeter. Yung youngest 4 millimeter to 10 millimeter, mas mataba siya. Then 1 millimeter. While yung planto naman natin is, kung i-compare is, yung youngest talaga yung mas mataba sa kanilang mga leaf width. So, nung day 21 naman natin is, yung sukat nito is sa centimeter na po. Yung oldest is 0.6 sa day 21, 0.6 din sa gitna and 0.5 centimeter. Yung youngest natin is 0.6 to 0.1 to 1 centimeter pala, not 0.1, and to 8.8 centimeter. Which yung mas malaki dito is yung ating plant 1 na oldest and youngest. Sa number of tillers natin sa ating day 14 number of tillers is sa plant 1 meron tayong 4 tillers and plant 2 natin is 2 tillers only. While yung day 21 natin is meron ng sa plant 1 natin is 9. Dagdagan siya ng 5 tillers and from 2 yung plant 2 naging 4, nadagdagan siya ng 2. And yung LCC natin is consistent siya na 4 and 5 nag-i-indicate na sapat lang yung natin, yung nitrogen sa lupa. So, ang ating next table po is yung day 28 and 35 o after transplanting natin. So, mag-start tayo sa plant height. At day 28, plant 1 nag-measured siya ng 50 cm and yung plant 2 is nag-measured ng 48.7 cm tall. Then nung day 35 na, parehas silang nag-grow ng yung plant 1 is nag-reach siya ng 60.5 cm and yung plant 2 natin is nag-reach naman ng 58 cm. And moving to leaf line natin. So, yung sa day 28 po natin, yung plant 1 ay nagpakita ng mas mahabang oldest leaf na 21.9 cm kumpara sa plant 2 natin na 16 cm. Nung index is nung move on tayo sa day 35, plant 1 maintained a longer leaf length compared to plant 2 natin, suggesting ng better growth under plant 1 treatment. And next, yung leaf width po natin. So, pinapakita po ng measurement na parang parehas lang po yung width nito, nagre-range ng 0.2 to 0.8 cm at day 28 and 0.4 to 0.9 at day 35. Both oldest and youngest. Maliliit lang naman po yung diferensya nila sa bawat leaf width. Kaya ayun. And next sa tillers, sa number of tillers natin sa day 28, meron tayong 14 tillers sa plant 1. While sa plant 1 natin we have a low 3 tillers, sobrang kakaunti. And sa day 35 natin is meron na tayong 31 tillers. And sa plant 2 natin sa day 35 din, sobrang laki ng in-increase niya. Meron na tayong 20 tillers. And yung LCC natin, ganun pa rin po na consistent siya na 4 to 5, meaning yung supply natin ng nitrogen is okay lang, maganda.
For the minus P or minus phosphorus element in minus 1 element setup using rice plant results to basic growth and development of crop under residual soil phosphorus. Residual soil
phosphorus means there are reserved phosphorus nutrient in the soil used in this experiment. The absence of supplemental phosphorus fertilizer results in clear deficiency symptoms like what we have here in this slide. For the first photo, we can see the older leaf yellowing, turning brown, and dies. And for the following photos, the early lower leaf yellowing is observed.
For the minus potassium plus urea plant, um, we can see that in the plant height, ma-observe natin yung pagtaas nito as weeks pass. But during week 28, bumaba ulit yung height. And this is because namatay yung tulos na pinagkukuhanan namin ng data, kaya humanap ulit kami ng bagong tulos. It is similar for the length part, but what I want you to look at is at the width part. So we can observe that it decreases over time, meaning habang tumatagal nagpapakita siya ng sign ng pagnipis. So this is one of the manifestations that it is deficient in potassium. We know that potassium strengthens the cell wall, and if a plant is deficient in it, then makikita yun sa pagiging mahina ng tangkay at later on pagnipis ng mga dahon due to stress. So potassium also helps in the regulation of water and promotion of roots. At dahil nga deficient siya dito, bumababa yung kakayahan ng plant na sumipsip ng tubig at mag-absorb ng nutrients. Kaya nahihirapan siyang mag-grow ng mga leaves niya. For the tiller part, makikita natin na as the weeks passes, tumataas lang din or dumadami lang din yung tiller or yung mga suhi na tumutubo sa kanya. And similar with the LCC.
Good morning everyone, my name is James Walder Reyes from Group 1, so I'm going to be discussing the nutrient deficiencies of potassium that we observed during the time we conducted the Moet treatment on rice crops. So before we discuss the nutrient deficiencies that we observed, I'm going to be discussing what does potassium do to our crops. So potassium does three things. So one, it regulates the water balance, which means nagiging drought tolerant ang ating crops, which is perfect sa ating climate na warm and dry. Second, nagpapatibay siya ng cell walls sa ating crops. Let's say, ang ating rice crops, yung example, ang kanyang tillers, mas maganda yung kanyang bunga, which means diretso yung kanyang tillers, imbis na nagpe-prevent din siya ng fog folding dahil nga matibay ang kanyang cell walls due to the potassium present. And lastly, nag-i-improve din siya ng grain yield quantity and quality. Makikita naman natin kung gaano kahalaga ang ating potassium sa ating crops. So, dumako na tayo sa ating nutrient deficiencies. So, sa day 14, ang aming na-observe, ang kanyang tillers is medyo folded ang kanyang tillers at saka medyo stunted kumpara sa other treatment. So, ang treatment kasi dito is potassium plus urea. So, urea or nitrogen. Okay. So, sa nitrogen, medyo lumago yung kanyang tillers. Mas konti pa yan nung day 7. Ngayon, ang potassium is nagkakos siya naging deficient siya sa potassium dahil na-observe naman namin yung kanyang paninilaw, and may isa pang nutrient na nag-cause bakit ganito yung aming tiller, which is folded yung kanyang tiller, folded and stunted. So dalawang nutrient ang napansin namin ang hindi siya present, which is potassium and phosphorus. So sa day 21 makikita natin yung epekto ng nitrogen. So compared to day 14 to 21, mas marami ang kanyang tiller. Kaso nga lang, ganun pa rin yung kanyang deficiencies, which is potassium and phosphorus. So day 28, ganun pa rin. Yung urea or nitrogen, mas lumalago ang aming tiller, and yung kanyang tiller naman mismo ay medyo folded pa rin, at saka compare sa ating treatment na medyo mas malaki ang kanyang tiller, kita dito yung epekto ng phosphorus na deficient siya na medyo stunted compare sa other treatment, let's say nitrogen, phosphorus, and complete. So day 35 or the last treatment, eto na, yung pinaka last week ng data collection namin, kita na natin yung pinaka final na growth ng aming Moet treatment na potassium. So ayan, malago na siya, and mostly sa throughout the 14 to 35 treatment is ganun yung kanyang deficiency symptoms, which is potassium and phosphorus.
Drawing all points together, the experiment minus one element using rice plant results that the rice plant were still able to produce panicles, shows growth and development of multiple tillers despite not receiving additional NPK nutrients in each treatment. This suggests that the natural nutrients in the soil used in this experiment were sufficient to support basic plant growth and production. However, the plants still showed visible deficiency symptoms because the amounts of these nutrients in the soil were not enough to meet the increasing demands of the growing rice plants. Let's now proceed to the comparison of minus nitrogen and complete. For minus nitrogen, although plants were able to develop multiple tillers and shows growth, compared to complete element, the lack of sufficient nitrogen resulted to yellowing of leaves and stunted growth. We can see in this slide the complete element is more lush and its leaves are taller, more green compared to the minus N element, where has stunted and doesn't have so much leaves. Let's now go on to the comparison of minus phosphorus and complete. In this experiment, the phosphorus deficiency or deficient rice plant, despite the development of panicles and tillers, shows early leaf yellowing. As we can see in this slide, a lot of minus P element has more yellow and brown lower leaves compared to complete element. And finally, the comparison of potassium and complete. The plant also still managed to develop tillers and panicles but has poor stress resistance. Potassium is essential for water regulation and overall plant health. With the heat index happening during the experiment, even if plants are regularly watered, lacking potassium hampers their ability to use the water effectively and cope with the heat stress, resulting to minus potassium deficiency symptoms like what we have here. In this slide, minus K treatment or element have lush leaves than complete element due to the other nutrients present in the soil and natural reserves. But the minus one element has more yellow and brown lower leaves due to potassium deficiency. And that would be all for the presentation of Group 1 in minus 1 element. Thank you and have fun learning.